Okay, so we'll look at section 8.3 here, which is simplifying radicals. And it's a very short section based on this product rule that you see up here at the top for radicals. And essentially what that says is the nth root of A times the nth root of B equals the nth root of A times B. So it just says as long as you have two roots and they're the same index up here, so being n, so they're both square roots, it's legal for us to multiply it, those two values underneath the square roots together, and it's still that square root. If they were both cube roots, then I can multiply those two pieces together, and then it's the cube root of whatever these two numbers multiply together to be, okay? So we'll scoot on down here then to example 1. These problems just say multiply and then simplify if possible. So in example 1, both of these are plain square roots. So using my rule up there, it says, okay, well then it's legal for me to go through and just multiply straight across. And so if you were to put in your calculator 15 times 27, you would get 405. Now, whenever they say simplifying, that's whenever we want to think about, since the square roots, we want to think about perfect squares. So remember from yesterday, our perfect squares were, remember 2 squared was 4, 3 squared was 9, 4 squared 16, 25, 36, 7 squared 49, and 8 squared 64, 9 squared 81, 100, and it just keeps going. But essentially, you're looking for the highest number in this list that will divide evenly into 405. And sometimes that's just trial and error, because 405 is not a number that just, jumps out at me as far as knowing what to pick for it. However, with that said, then you just, like I said, go in your calculator, 405 divided by 4, 405 divided by 25, and just sort of see what happens. You wouldn't want to pick anything that had a remainder. Okay, it has to be a nice whole number. And it should happen in your calculator if you were to do 405 divided by 81, that it would be perfect, 81 times 5. And I picked 81 because 81's there in my list. And we know the square root of 81. Square root of 81 is 9, so it comes outside the house, and 5 stays inside. Final answer. If we move on down to example 2, both of these are cube roots, so it's still legal for me to use my property from above. I get to still keep it a cube root, and I get to multiply 4 times 20, which is 80. Now here, whenever you're thinking about breaking it down, we can't use this. This is the square root list. Square root list. Now, if you were going to break it down in the same way, you would need to think about a cube root list. And so cube root list is like saying, okay, 2 cubed is 8. 3 cubed is 27, 4 cubed 64, 5 cubed 125, and I wouldn't need to go any further here. I would start now, taking 80 and dividing it by these values here, but we can, hopefully that one's pretty obvious to you. You know that 8 will go into it. 8 times 10, and then the cube root of 8 is 2, so that comes outside the house. And you leave that 10 inside. So 2 times the cube root of 10. Final answer. Okay. We move on down below. I guess I'll just probably end up working through the majority of this set of notes and kind of tell you like I did in the last one. If you want to, pause the video at any point and try one on your own and then hear me go through it, that's probably a good practice as well. Okay, so alright, so I'm going to look at this next one. So it's another cube root times another cube root, so it's legal for me to use my property. So this would be the cube root. 5 times 2, of course, is 10. AB squared. Now, when I have the cube root of 10, there's not a number in this list up here for my cube roots that will go into 10 evenly, so I'm not going to be able to break up the number evenly. And A and B squared, I can't make them any multiples of 3, so this is your final answer. We move on down to the next one. This is a 4th root times another 4th root, so it will be the 4th root. Multiply, add these exponents, so that would be x to the 5th, y to the 4th. I'll be able to go further because all that needs to happen underneath here is that these exponents, if I can make them multiples of 4, then I need to do that so that I'll be able to take the 4th root of it. So I have the 4th root. I can rewrite x to the 5th as x to the 4th times x. And then y to the fourth is already a multiple of 4, so just leave it alone. And now come through and take the fourth root of all the pieces that we can. So the fourth root of x to the fourth, it's just x. So that one's coming outside the house. The fourth root of y to the fourth, that's just y. So that's coming outside. I'm not going to be able to do anything with this x here in the center, so that's going to stay inside, and that'll be part of your final answer. So xy on the fourth root of x, final answer. Okay, we flip it on over. The next page, you will see the quotient rule for radicals, and all that says is that if you have the nth root of a divided by that same root, the nth root of b, that 2 square roots is equal to 1 big one. Okay, so we'll just come down here to example 1. They say divide and simplify if possible. So the square root of 90 divided by the square root of 10, so 2 square roots is the same as 1 big one, so 90 divided by 10. Okay, well, we can simplify that further. 90 divided by 10 is just 9, and the square root of 9 is 3. Hopefully very straightforward on that one. The next one, you've got a cube root divided by another cube root. The 5 is just going to stay on the outside, and then it will be the cube root of, well, maybe I should show my work here. Let's do it this way. 5 on the cube root of those 2, it would be 32 divided by 2. Like that. Then that would be 5 on the cube root of 16. Now a cube root of 16, you can't multiply anything times itself 3 times to get 16, but you think about that cube root list that was on the previous page, and 8 was the first one. Eight was the first number in that list, so I could rewrite this as 5 on the cube root of 16 is the same as 8 times 2. Now I know the cube root of 8 is 2. So I'm going to pull that 2 outside and multiply it times this 5 that's already sitting out here. And so that's going to turn into 10 on the cube root of, and then this 2 is the one that's staying inside the house. So 10 on the cube root of 2 is final answer. Okay. Moving on down to example 3. It's a square root here, so you'll want to be able to take the square root of the numbers, and then you'll need your exponents underneath the house here to be multiples of 2. Okay, so I have now the square root of 16 up top, x cubed. X cubed I can rewrite as x squared times x. And then on the bottom, y to the fourth is already a multiple of 2, so I can just leave it alone. And now I'm just going to come through and take the square root of everything that I can. So the square root of 16, 4. Square root of x squared is x. Square root of y to the fourth, y squared. And then I still have this x up top, so I just leave it up top. So 4x times the square root of x, all divided by y squared. Final answer. Okay. Down here below, you've got one big square root already, and it's the cube root, so I just need everything in here to be multiples of 3. And then number-wise, I need to be able to take the cube root, and actually 27 and 343 are already perfect cubes, so I can just leave those alone. And I would have 27. Y to the fifth, I can write that as y cubed times y squared. So I still have 5 y's, I just now have at least one term, though, that will be a multiple of 3 that I'll be able to simplify further. Then on the bottom, I have 343, and the x cubed is already a multiple of 3. And then I come through and take the cube root of everything that I can. So the cube root of 27 is 3. Cube root of y cubed is y. Come down to the bottom, cube root of 343 is 7. Cube root of x cubed is x. And then I'm just left with that cube root of y squared up top. And that's your final answer. Okay. Let me know if you need anything. Thanks a lot. Bye.